In this presentation, we will try to understand what are dangling pointers. So let's get started. What is a dangling pointer, by the way? A dangling pointer is a pointer which points to some non-existing memory location. It is a special type of pointer which points to some non-existing memory location. For example, here in this case, PTR contains the address of the first byte of the memory allocated by malloc. Let me tell you that malloc is the function which allocates memory dynamically. I have already gave a glimpse about this in the previous lectures. Malloc is the function which allocates memory dynamically. After allocating the memory, malloc simply returns the address of the first byte of the memory. And that address I am trying to store here in this PTR pointer, right? So PTR contains the address of the first byte of that memory location. After performing some operations, now what I am trying to do here is, I am trying to free the memory. That is, I am trying to release the memory, or I can say I am trying to deallocate the memory. So malloc has allocated some memory. After performing some operations, I am just deallocating the memory using this free function. It is a special type of function which we will discuss later. Right now you should understand that this function is used to deallocate the memory allocated by this function malloc. Okay? So here in this case you can clearly see that we are deallocating the memory after using the memory. But you should understand this point also, that the pointer PTR is still pointing to the deallocated memory, isn't that so? Let us assume that the address of the first byte of the memory is 1000. PTR still contains that address even after deallocating the memory, because we haven't reinitialized the pointer, as simple as that. After releasing the memory, PTR is still containing that address. That is why PTR is called a dangling pointer. Why is that so? Please see the definition once again. A dangling pointer is a pointer which points to some non-existing memory location. When you free the memory, when you release the memory, after that pointer becomes dangling because it is pointing to the non-existing memory location. After deallocating the memory, memory doesn't exist, but pointer is still pointing to that memory. This is called dangling pointer. Okay? What is the solution for this problem? Solution is simple, just reinitialize the pointer. Now here in this case, PTR has been initialized with null. Obviously this is the simplest possible step. Just initialize the pointer with null. Now this is legal, right? So PTR is no more dangling. Dangling pointers cause problems later in your code. If you free the memory which has been previously allocated, then maybe you try to dereference the pointer and try to access the contents from that location, but that location simply doesn't exist. So to avoid such problems, obviously, we need to reinitialize the pointer once again after freeing the memory. This is very important step. Now, let's consider example number 2. Here in this case, you can clearly see I have a function fun and obviously I have a main function. Within this main function, we have a PTR pointer which contains null. Initially, obviously, this is the best practice. I have already talked about this. PTR is the pointer. Right now it is not pointing to any object, so it is better to initialize it with null. After that, what we are doing here is we are trying to call this function fun and we will store the address returned by this function within this PTR. Okay? You can clearly see within this fun function, we have a variable num which has been initialized with value 10 and we are trying to return the address of this num variable. You can understand that num is a variable which is local to this function. Isn't that so? When this function finishes its execution, then obviously this variable gets vanished. This is the meaning of a local variable, right? This variable is local to this function. As long as this function exists, this variable exists. But after the execution of this function, the variable will simply doesn't exist. So it is just like deallocating the memory, and that too automatically. So when we try to return the address of this variable, obviously we are trying to return the address of non-existing memory. Here we are trying to store that address within this PTR pointer. So obviously this PTR becomes a dangling pointer. And here we are trying to dereference it. So it will cause segmentation fault. Segmentation fault simply means that you are trying to read or write into an illegal memory location. Here you can clearly see that num is local to this function. After function finishes its execution, num variable will get vanished, which means that it will no more exist. Obviously, this means that memory has been deallocated and we are trying to return the address of the deallocated memory, and this simply means that we are trying to return the address of a non-existing memory, right? That is why segmentation fault occurs. So obviously it is important to avoid such practices. Try not to return the address of a local variable from a function. Okay friends, this is it for now. Thank you for watching this presentation.